Okay, so I think thank you for inviting us. So me and Gerald from Greatearth. So I'm the senior BEAMP manager for China Construction. So I would like to thank the CA and Yopadang for inviting us and somehow study most of our proposals that problems at site that could find some digitizations as well. So I think for this one, we actually have three problem statement. Hopefully, we can really be productive and have some answers on that. So I think our statement for the problem for today is we would like to somehow study on augmented reality to maximize use augmented reality for visualization on site. And specifically, we want to test this out with precast project, precast element installation and inspection. So it could have some potentials in the future, but now I think we would like to focus there first. So the background of this problem is that is basically specifically focused on precast, such as columns, beams, precast beams, columns, and slab planks. So key problem is that once we actually construct these elements and then delivered to the site, um, it actually takes a lot of manual and tedious coordination for the accuracy of the installation. And we're talking about different types of people here, different types of level, from engineers, workers, down to operators of cranes and everybody. So in most of our projects using precast, definitely. Oh, sorry, you go back first. Okay. Actually, we have tons, actually thousands of precast elements, and it's a repetitive work, and it is a lot of elements, including the site to be very dynamic as well. So in current practice, currently right now, what happens is that without this system, we actually communicate verbally. Everything is done manual. Even though we have BIM models and we have some digital inspections that we actually implement in some projects, we don't have that AR or augmented reality capacity within the software, whereas we can really verify installation of the elements based on its orientation, location, using AR. We don't have this. Everything we have some digital applications for inspection, but we really don't have this function. So current installation, as mentioned, is manual work. Installation team uses simple markings and manual measurements methods to determine the positions. So as I mentioned, so after installation, inspection process will require process of cross-referencing drawings as well and documents and drawings. So there's a lot of this cross-referencing of data. So the impact of the current practice is that there's a big disconnect of the digital drawings and the actual reality inside. It could be misaligned. So I hope within this proposal, this can actually try to settle that. Okay, next slide. I will ramp up. So this is an example of model that we have. As you can see, the model is actually properly aligned and orientated. So our imagination is that if we can develop a system that it could project and use AR and see the actual orientation on site so that it could be easily matched by the workers once they do the installation. Okay, next slide. Sorry. And some of the process that we are actually trying to take a look at. So basically, the process would cover from this the preparation of the documents such as the QR codes into the site office, so that once we go to the site, it is as just simple as scanning the QR code and then using your tablet or mobile phone to actually see the augmented reality model that we use. So this can be used to verify the installation of site, or it could also verify, the inspection, the quality of the work of the site itself as well. Next slide. So our ideally is going to be like this. All of the data will be prepared where we have the correct orientation of all of the precast elements, given the locations. And then within the shot drawings that we have, we can actually try to include the QR code. And then once we scan the QR code, we can actually see the model augmented within the real world using our cameras or tablets. And then by then we could actually do, maybe I think we could potentially do comments and feedbacks as well in the future. Okay, next. And the solution, I think this will help inspector to visualize installation requirements, and then operable from mobile device and tablets. And kind of right now, the priority, as mentioned, is structural elements. But I think once we have the systems up, we could actually try to expand it more in the M&E system or architectural in the future as well, in all of the elements. Yeah, and expected outcomes. This will assist our site staff, engineers, all of the stakeholders to visualize better in 3D and support better execution of precast elements installation. Yep. I think that's it for us.
Yep. Thank you, Rob, for your presentation.
Okay.
So the first question that we received, right, is from our audience is, what is the detailed system, the IDD systems that you already have in place?
In the project that we're taking a look at, we got an overall IDD system called Fulcrum. It's a New Zealand-based system. So it has everything from document management and safety, quality, everything. It has everything. So even our inspection quality, inspection forms is there. So we're thinking to somehow integrate it within that system, or we are quite open as well that it could be a proprietary separate system if the integration is quite difficult. But our CDE system or IDD system actually is quite open for integrations also. So I think there's no problem. We can open the APIs.
Mm-hmm. Yep. Rob, actually, I do not have any more questions. I'll just wait a few seconds to see whether there's any questions that pop up.
Sure.
If there's no further questions, then yeah, I will just spare you from the stage. Yeah.
Problem. I hope
No questions coming in yet, but yeah, questions can be sent to us at bm@padang.co. Yeah, even after the session.
Okay, no problem. Yep. Okay.
All right.
Thanks.
Thanks, Rob, for sharing more about the challenge.